This lecture covers Chapter 1, Section 3. In Chapter 1, Section 3, we will be reviewing collecting sample data. When using statistics in a study, planning is very important, and it is essential to use an appropriate method for collecting the sample. This section of Chapter 1 includes a discussion about the various methods and sampling procedures. Of particular importance is the method of using a simple random sample. Keep in mind that if a sample is not collected in the appropriate way, the data may be of no value to us in our study. It is essential to use the most relevant and useful sampling method for every statistical study. Randomization with placebo and treatment groups is sometimes called the gold standard because it is so effective. A placebo is a sugar pill that has no medicinal effects. These types of studies are considered to be the gold standard because they deliver the highest level of evidence due to their potential to limit all sorts of bias. Statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources: observational studies and experiments. An experiment deliberately imposes a treatment on a group of objects or subjects in the interest of observing the response. This differs from an observational study, which involves collecting and analyzing data without changing any of the existing conditions. Experiments apply some sort of treatment, and then we proceed to observe the effects of that treatment on the individuals. The individuals in an experiment are called experimental units, and they are also often called subjects when they are people. For example, a study took a group of adults and randomly divided them into two groups. One group was told to drink tea every night for a week, while the other group was told not to drink tea for that week. Researchers then compared when each of the group later fell asleep. In this example, the treatment would be drinking the tea. One group was given the treatment and they were allowed to drink the tea, and the other group was not given a treatment. They did not drink the tea. In observational studies, we observe and measure specific characteristics without attempting to modify the individuals being studied. An example of this would be a study took a random sample of adults and asked them about their bedtime habits. The data showed that people who drank a cup of tea before going to bed were more likely to go to sleep earlier than those who didn't drink the tea. In this example, there was no treatment of the tea. The subjects were simply asked whether or not they drank tea before going to bed. Let's consider another observational study, this one with a lurking value. Let's say a researcher observes past data and comes to the conclusion that ice cream causes drowning, based on the data that shows that increases in ice cream sales are associated with increases in drowning. The mistake here is to ignore the lurking variable of temperature and the failure to see that as temperatures increase, ice cream sales also increase, while at the same time more people go swimming, and therefore the number of drownings will increase. A lurking variable is a variable that is not included in the statistical analysis, yet has an impact on the relationship between two variables that are being considered in the analysis. If we wanted to find out if eating ice cream is associated with an increase in drowning, we can conduct an experiment in which one group is treated with ice cream while another group gets no ice cream. we would see that the rate of drowning victims would be about the same in both groups, and so we would conclude that there is no evidence that eating ice cream is associated with drowning. Experiments are often better than observational studies because a well-planned experiment will reduce the chance of having results that are affected by some other variable that is not part of the study. Now let's consider some design of experiments. A well-designed experiment will include replication, blinding, and randomization. Let's take a look at these three terms. Replication is the repetition of an experiment on more than one individual. In other words, in experimental design, replication is where each treatment is assigned to many participants, or the entire experiment is repeated on large groups of subjects. Good use of replication requires sample sizes that are large enough so that we can see the effects of the treatment. Blinding is a technique in which the subject does not know whether he or she is receiving a treatment or a placebo. Blinding is a way to get around the placebo effect, which occurs when an untreated subject reports an improvement in symptoms. Conducting blind experiments removes the bias of the research subjects and sometimes of the researchers themselves, thereby helping to avoid biases in our results. In double-blind studies, the blinding occurs at two levels. In the first level, subjects don't know whether they are receiving the treatment or a placebo. In the second level, the experimenter doesn't know if he or she is administering the treatment or a placebo. In clinical trials, blinding is when a patient does not know what treatment they are receiving. They could be getting either a placebo or the actual drug being studied. Blinding also refers to the practice of keeping the name of the treatment hidden. For example, a patient might know that they are involved in a trial for arthritis, but they will not know the name of the brand of the medication that's on trial. In a double-blind trial, the clinical team also does not know whether the patient is receiving the placebo or the treatment. Randomization is used when subjects are assigned to different groups through a process of random selection. The logic behind this is to use chance as a means to create two groups that are similar. For example, you might use a simple random sample where participants' names are drawn randomly from a pool where everyone has an equal chance of being chosen. You might also assign treatments randomly to participants by assigning random numbers from a number table. If you are using randomization in your experiment, you can guard against bias. For example, selection bias, where some groups might be underrepresented, is eliminated, and accidental bias, where the chance of imbalance happens, is minimized. You can also run a variety of statistical tests on your data if you know your sample is random. With a simple random sample, a sample of n subjects is selected in such a way that every possible sample of that same sample size has the same chances of being chosen. For example, if we put 100 numbered bingo balls into a bowl, this bowl of bingo balls represents the population. If we select 10 balls from the bowl without looking, this is your sample of size 10. A simple random sample is chosen in such a way that every set of individuals has an equal chance to be selected as the sample. While this method works fine for smaller populations, in reality you'll be dealing with much larger populations, and so you'll have to utilize different sampling methods. Another type of sampling is called systematic sampling. When you're sampling from a population, you want to make sure that you're getting a fair representation of that population. Otherwise, your statistics will be biased or skewed and perhaps meaningless. One way to get a fair and random sample is to assign a number to every member of your population and choose the nth member of that population. For example, if you work in the car manufacturing industry, you might want to select every third car that comes off the line to test the safety of its seat belts. So you could test the third car, and then the sixth car, and then the ninth car, and so on. Convenience sampling, also called accidental sampling or grab sampling, is where you include people who are easy for you to reach. For example, you could survey people from your workplace, people from your school, a club you might belong to, or the local mall. Convenience sampling doesn't include a random selection of participants, and therefore there is a high risk that your sample will not represent the population. However, sometimes a convenience sampling is the only way you can drum up participants into your study. Stratified sampling is used when your population is divided into strata, or characteristics like gender, education level, or the region where people live. And you want to include the stratum when making your sample. The stratum may already be defined, like in census data. The census often uses county data. Or you might want to make the stratum yourself to fit the purposes of your research. Stratified sampling is very similar to random sampling. However, these samples are more difficult to create as you must have detailed information about what categories your population falls into. Cluster sampling is used in statistics when natural groups are present in a population. The whole population is subdivided into clusters or group, and random samples are then collected from each of those groups. Cluster sampling is typically used in market research. It's used when a researcher can't get information about the population as a whole, but they can get information about specific clusters. For example, a researcher might be interested in data about city taxes in Florida. The researcher could compile data from selected cities and compile them into a picture about that state. The individual cities would be the cluster in this case. Cluster sampling is often more economical and more practical than stratified sampling or simple random sampling. Multi-stage sampling divides large populations into stages to make the sampling process more practical. A combination of stratified sampling or cluster sampling and a simple random sampling is usually used. Some examples of multi-stage sampling include the U.S. Census Bureau. The U.S. Census Bureau uses multi-stage sampling for the U.S. National Center for Health Statistics. They use a multi-stage sample of 42,000 households within 376 sampled counties. So the first stage of the sampling would be to sample the 376 counties, and then within those counties the second stage would be to sample the 42,000 households. Johnson & Johnson also uses multi-stage sampling when they conduct survey on drug use in high schools. They use a three-stage sampling process. They sample from geographic areas, followed by high schools within those areas, and then followed by seniors who attend those high schools. Now let's look at different types of observational studies and different ways of designing experiments. Let's start with observational studies. Recall that with observational studies, we observe and measure, but we do not modify. There are three types of observational studies. The first is a cross-sectional study. In cross-sectional studies, data are observed, measured, and collected at one point in time, and not over a period of time. You can interact with individuals directly, or you could study data from a database or other media. For example, you could study medical databases to see if illegal drug use results in heart disease. Cross-sectional studies can be very inexpensive to conduct if you already have a database. And they allow the researcher to look at many factors at the same time, like age, weight, height, tobacco use, drug use, etc. However, the available data may not be suited to your research in question. For example, if you want to know if sugar consumption leads to obesity, you are unlikely to find data on sugar consumption in a medical database. Also, cross-sectional research studies are usually unable to control for confounding variables. Retrospective studies, the data are collected from past time periods by going back in time through examination of records or interviews, etc. In other words, all cases have already happened before the study begins. Researchers then look back in time using questionnaires, medical records, and other methods. Basically, you're just digging into the data and see what you can find. The goal is to find out what potential risk factors or other associations and relationships the group has in common. Some advantages of a retrospective study is that they require smaller sample size. Studies like this take less time because the data are already available. It just has to be collected and analyzed, and the costs are generally lower. Some disadvantages include the risk of not knowing if there might be any missing data, or if the participants had any difficulty recalling important information. This difficulty in recalling important information is also known as recall bias. And finally, prospective or longitudinal data are collected in the future from groups sharing common factors. This group would be called a cohort. An example of this type of study is when the participants are enrolled into a medical study before they might develop any specific disease. The prospective study typically lasts a few years and sometimes for decades. You've already heard me use the term confounding on previous slides, so let's discuss the definition of confounding. Confounding occurs when the experimenter is not able to distinguish between the effects of different factors. A confounding variable is an extra variable that you didn't account for. They can ruin an experiment and give you useless results. They can suggest that there is a correlation when in fact there is no correlation. They can even introduce bias. That's why it's important to know what a confounding factor might be and know how to avoid getting them into your experiment in the first place. Recall our example about the study to determine the increase in ice cream consumption being associated with the increase in the number of drownings. In that example, temperature was one of the possible confounding variables. As temperature increases, more people are more likely to consume ice cream. At the same time, people are more likely to go swimming, and thus leading to an increase in deaths. So the experimenter would have been wise to consider that temperature would have an effect on both of those variables and then have an effect on the study. To ensure we have a meaningful study, it is important that we control the effects of the variables. We can do this with the experimental design of the study. Experimental design is a way to carefully plan experiments in advance so that your results are both objective and valid. Completely randomized experimental designs assign subjects to different treatment groups through a process of random selection. Every experimental unit has the same odds of receiving a particular treatment. This design is usually only used in laboratory experiments where environmental factors are relatively easy to control for. It is rarely used out in the field where environmental factors are usually impossible to control. Another experimental design is called the randomized block design. A block is a group of subjects that are similar, but the blocks differ in ways that might affect the outcome of the experiment. In randomized block design, the researcher divides experimental subjects into homogeneous blocks. The treatments are then randomly assigned to the blocks. The variability within blocks should not be greater than the variability between the blocks. In other words, you want to make sure that the block contains subjects that are very similar. For example, you could put males in one block and females in the second block. Another type of experimental design is called matched pair design. Matched pair designs compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. Matched pair designs is a special case of randomized block design. In this design, two treatments are assigned to homogeneous groups or blocks of subjects. The goal is to maximize the homogeneity of each pair. In other words, you want the pairs to be as similar as possible. The blocks are composed of matched pairs which are randomly assigned to a treatment. Another type of experimental design is called rigorously controlled design. In these types of experimental designs, the subjects are carefully assigned to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. An example would be if you want to have a full-time student who is male, taking only night classes, has a full-time job, and has children in one of the treatment groups, then you need to have that same type of student getting the other treatment. This type of design is hard to implement since you don't know how many differentiations you would use. Let's consider a few different types of errors that may occur during a statistical study. Errors happen when you take a sample from the population rather than using the entire population itself. In other words, it's the difference between the statistic you calculate on your sample and the parameter you might calculate on your entire population. If you were to survey an entire population, there would be no error. However, when you take a sample at random, you estimate the error, and this estimate is called the margin of error. Sampling error, or random sampling error, occurs when the sample has been selected with a random method. But there is a discrepancy between the sample result and the true population result. Such an error results from the chance of sampling fluctuations. Non-sampling error is the result of human error, including such factors as the wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances. Non-sampling error occurs during data collection, causing data to differ from the true values. The higher the number of errors, the less reliable the information is, and the rate of bias in the study goes up. And finally, non-random sampling errors is a result of using a sampling method that is not random, such as using a convenience sample or a voluntary response sample. This is the end of chapter 1. I'll have the homework assignment posted pretty quickly. My office hours, again, will be Wednesday and Thursday from 7 to 8:30. Feel free to contact me via Zoom for my office hours if you want to go over any of the lecture or if you want to go over any of the homework assignment.